Hi, hello. Welcome back to a new video. So, in the last lecture, we had seen about the chemical modifications. Today we are going to see the miscellaneous method, which is used for the enhancement of solubility. So, we'll see what are the miscellaneous method. Why this miscellaneous method is required. So, this miscellaneous methods are the special methods which are used to enhance the solubility. Okay. So here we can see supercritical fluid process, sonocrystallization, microemulsion, and use of adjuvants like surfactant, solubilizer, co-solvency, hydrotrophy are the miscellaneous method which is used to enhance the solubility. So first we will see what is supercritical fluid process. Supercritical fluid process means you are using a fluid, the fluid like carbon dioxide above its critical temperature and pressure. So here we are using a fluid which is above a critical temperature and pressure. Then in that fluid we are going to dissolve our drug, okay, which is then rapidly will get expanded due to the temperature and pressure. So this rapid change forces the drug to precipitate ultra-fine and uniformly sized particles. So this sudden change in the pH, the rapid change in the pH will make our drug to precipitate as a ultra-fine. So this ultra-fine will be uniform sized particles. So the uniform sized particles will enhance in the solubility. So this is by particle size reduction. So supercritical fluid process is the principle is particle size reduction. So next we will see the sonocrystallization. So the sonocrystallization principle also is based on the particle size reduction only. So how we will see? So here we are using a ultrasound energy. What we are using? Ultrasound energy or sonication. So during the crystallization process, the acoustic energy promotes the rapid and controlled nucleation, so resulting in the formation of very small, high energy and often porous nanocrystals with improved solubility and dissolution rate. Here also the sonication, the continuous sonication will make a nano size or fine sized very small particles, so which will improve the solubility as well as bioavailability. Here a fluid we are using, its critical temperature and pressure. Okay, in here we are using sonication or sonication for particle size reduction. So next one is the microemulsion. Here also the particle size reduction only. So here microemulsion means what? A clear, stable, isotropic liquid mixture of oil, water, surfactant and co-surfactant. So we are going to dissolve our drug in the oil phase, okay, so which is dispersed as extremely tiny droplets. We will get the tiny droplets in the size range of 10 to 100 nanometer. So this we can stabilize by adding the surfactants. So this will providing a highly effective solubilization system. So we know emulsions are thermodynamically unstable, but in the case of micro emulsions we are reducing the particle size up to 10 to 1000 10 to 100 nanometer, which will provide a highly effective solubilization system and will make the system stable. So in this three supercritical fluid process, sonocrystallization and microemulsion, we can see the particle size reduction for the enhancement of solubility. So next we will see the use of adjuvant. So coming to the adjuvants, the first one is the surfactant. Surfactant are solubilizers or solubilizing agents. Okay. So these are amphiphilic molecules. Amphiphilic molecules means what? It is having a hydrophilic head as well as hydrophobic tail. Okay. It is having the two portions. So above a certain concentration, above the certain concentration, that means critical miscellaneous concentration. CMC means what? Critical miscellaneous concentration. Critical miscellaneous concentration. So in that concentration, they will form the miscellaneous. Okay. So a poorly soluble drug can be entrapped in the hydrophobic core of the miscellaneous. Okay. In the hydrophobic core, the poorly soluble drug will get entrapped, so making it highly soluble in the aqueous medium. This is what the surfactants will do. So surfactants or solubilizers are the agents which is used to enhance the solubility. Okay. So the next is co-solvency. In the case of co-solvency, we are using a mixture of water and one or more water miscible organic liquids. So to increase the solubility, especially for poorly soluble water soluble drugs, right? So we are adding a water miscible organic liquids, like another solvent which we are adding to increase the solubility, like co-solvents, like we will add the ethanol, propylene glycol, okay, which will reduce the polarity of the solvent, which will reduce the polarity of the solvent. Okay, so this makes easier for poorly soluble hydrophobic drugs to dissolve. This is the mechanism of co-solvency. If we use the another solvents with water, which will gradually will increase the solubility. The last one is hydrotropy. What is hydrotropy? So what hydrotropy will do? Using high concentration of a third substance. So the third substance is called hydrotrop. What? Hydrotrop. So for example, sodium benzoate. Okay, what? Sodium benzoate, as well as we can use sodium salicylate. Okay, as well as we can use urea. Okay, these are hydrotrops. Okay, so this hydrotrop, what will do that it will increase the solubility of the drug. Okay, the hydrotrop will interact with the drug and water to break up drug aggregation without forming the miscellany. This is what hydrotrops will do. Hydrotropy. So hydrotrop will give the a new solvent environment. So we can act as a co-solvent also. The hydrotrops is a third substance which is used to enhance the solubility. Okay. So we'll see once again in the first three: supercritical fluid process, sonocrystallization, and microcrystallization. We had seen the particle reduction to enhance the solubility. So in the supercritical fluid process, we are giving the high pressure as well as the temperature. So this sudden change will, the rapid change will help reduce, means our drug will get precipitated into the ultrafine particles, so thereby we are getting the increased solubility. In the case of sonocrystallization, sonication is taking place. There also we are getting the very small particles. So the very small drug means we can gradually the solubility will increases. In the case of microemulsions, we are getting a stable emulsions in the size range of 1 to 100 nanometer. Okay, so the adjuvants, which are the substance, all the which are the adjuvants are the agents which are adding to our formulation to increase the solubility. Okay, surfactant and solubilizers, co-solvency, hydrotropy. So this is the end of our solubility enhancement method. So we had discussed the complete physical modification, chemical modification, as well as the miscellaneous method. I hope you people understood. If you are having any queries or any doubt, please comment in the comment sections. I will be helping you out. Okay, so thank you for watching. We'll see you in next video. Bye bye.